So thermal camera, what actually is a thermal camera? A thermal camera effectively is a type of device that allows you to measure temperature efficiently. So whether it's an environment, a normal fire, or whatever it is. But in this particular case, it's designed to measure body temperature. So thermal cameras are kind of all the rage at the moment as far as measuring temperatures of people coming into buildings, especially with COVID-19 going around. It's a way of effectively measuring people's temperature quickly and efficiently. So you don't have to have someone standing there, stopping, scanning your temperature, then moving in, having a backlog created outside where the virus can even spread more because you're not social distancing. So it eliminates that process. But this camera itself has some more features in that it's got like a little LED flashing light. So if someone does come into the building that's got a high temperature, the light can flash. You can actually got a little speaker there saying, you know, your temperature's abnormal. Other cool things is that you can get that, if that person comes in with a temperature, can be notified to your phone. You can have on your laptop sitting there, so you can actually record that person's face with the temperature that's actually recorded, kind of giving you a bit of a traceability fact. But actually, how accurate is this camera? Does it actually work reliably? Well, we're about to find out. Okay, so here's what we're going to do. We've got our thermal camera from HikVision, which we've just unboxed. We've also got this forehead thermometer thing, which scans your forehead. I'm sure you've seen these around. Every time you walk into a building now, you're getting something scanned on your head. And then we've actually got an ear thermometer. So we'll stick that in our ears, see what that produces as a temperature. And then we've got this thing, or this old-fashioned thermometer. We can either stick this in our mouth, or other places, I guess, is, Georgie, do you want this one? We can stick this where places don't shine. Are you sure? Okay, so anyway, so once we've got all these measurements and we can test it through our different measuring devices, we're going to go and do an entrance test. So we'll set up the camera, and as you walk into the building, we'll capture temperature, and then each step along the way, we'll use a device to measure it and compare it. Then we'll jump into having the camera in a main room, so away from a door or an entrance, and then see what all those results produce once again. But the next thing we're going to do is we're going to try and trick all of these devices and see if we're actually going to be allowed into a building based on what we do. So we're going to do a running test. So we'll run around the block, get our temperature up, and then measure our temperature from that. Maybe do a beanie test. So we'll stick on a beanie, see if it raises our forehead temperature, see if that lets us go in. And then maybe what we'll try and do is maybe we'll try and cool our temperature. So maybe that's through a glass of water. Maybe we'll stick our head in the freezer. What do you reckon? Maybe we'll stick our head in the freezer. But we'll just see. We'll see what happens here. But from that, we'll compare all these results, show you what it is. We've got no idea what's going to happen, but we're really excited to see the results. So here we go. We've got our camera all set up on our tripod. So according to HikVision specs, this camera has to be running more than 40 minutes, which in this case, it's been running more than a few hours now. It's actually set to 1.5 meters high, and we're going to be measuring a distance temperature of 1.5 to 3 meters. So to figure this all out, we're actually going to measure outside, inside temperatures as well. So we're going to be using this product from Nilex. It's actually got a little temperature monitoring device outside. Currently it's saying outside it's 14.8 and inside it's 15.6. So the first test we're going to do is an entrance test. So what we're going to do here is we've set the camera up inside just before you walk into the door. And what we're going to do is we're going to go outside, wait 5 minutes, acclimatize, walk back in, check our temperature, come back out, acclimatize, walk back in, we'll repeat that 3 times. So what's the point of doing that? Basically trying to simulate, if you're in a, like say a nursing home, a shopping center, even an office environment, you can capture those people before they get further into the premises and then stop them from moving forward into the building. It's gone now.
Cool, we don't have to use it.
So I went to put this in my mouth and I've broken it. So we can't use this anymore. Oops. So guess what, George? You don't have to use this anymore. Is that good? So we can't really use this anymore because it's broken. I don't have another one, so we're just going to have to make do with our forehead and our ear thermometer for now. So hopefully that will still give you some accurate results. All right, so next test we're going to do is actually going to run around our unit complex, measure our temperatures again and see what type of results we get. There is a bit of a cool breeze going on, so I'd be interested to see how that actually affects skin temperature. and how that all plays out. So the next test we're calling the beanie test. So the purpose of this test is to see if wearing a head covering such as a hat or beanie is going to affect the ability to read and measure temperatures. So how's this going to work? We're going to get our beanie, we're going to put it on for 15 minutes, we're going to take it off, measure our temperatures and repeat that process 3 times. So it's time to cool my temperature down. Spoke about earlier about sticking my head in the fridge. I've actually got a fridge here. I think it's pretty cool. We can kind of cool that down real quick. Do you reckon we do it? All right, let's have a go. Georgie? Georgie, I don't think this is really working very well. I think we need to try something else. Well, the freezer didn't work, so we found 2 bottles of cold water. So what I'm going to do is I'm going to stick one on my forehead, see if that brings down the temperature, and then we'll see what type of results we get from that. Get an error. So we actually found some interesting results when we just put this bottle of water on our forehead. It still was pretty good. So we thought, let's get 2 bottles and see if it's measuring eye ducts. It might look a bit stupid, but let's see how this looks. Wow, this is really cold. So the last test we're going to do is the indoor test. This is how the camera was designed to be set up. It gives the camera a better chance of measuring temperatures more accurately. So what we're going to do is we're going to go backwards and forwards, measure our temperature 3 times and see what type of results we get. Well, here we are. We've done our tests and have the results. One thing I want to make out is that you see thermal cameras have not actually been approved medically to measure body temperature. So it really can only be used as a guide, but how effective is this camera still at measuring temperatures? When we started doing our tests, we actually found that the camera was 1 degree off when compared to, say, our other thermometers that we had. So what we did is then we manually went in, we calibrated this camera to give us a more accurate reading. So, you know, for example, in comparison to our ear thermometer, and we couldn't use the oral thermometer because we actually broke this during the test. You see the temperatures listed that you're going to see are based on an average of 3 tests. We found that after numerous tests using the ear thermometer that my body temperature actually came to on average 37 degrees, which is normal. From there, we used this as a base to compare all devices. What we did then is we measured the inside and outside temperature to make sure that when we're using all these devices, we're actually within the manufacturer's specifications. What you'll see later on at the end of the video, you'll have all the model numbers of the thermometers and you can check them out there as well. So first test was the entrance test. When we started doing this test initially, we were getting all kinds of different results. And then after a few tests, we noticed that depending on which way we're standing towards the sun, it would produce a different reading. So based on that, we decided to do 2 tests. One where we were facing the sun and the other whilst our back was to the sun. So here's some results. So back to the sun, the outside temperature was actually 21.3 degrees and the inside temp was 18.6. When we measured our forehead, we had a reading of 35.2. When we measured our ear was 37.1, and then the thermal camera measured 36.8. So when comparing it to the ear, there's actually only a difference of 0.3 degrees, which is not bad. And then here we go when we're facing the sun. So outside temperature was 23.3, the inside temperature was 20.5, and we had a base forehead reading of 36.5 and a forehead reading of 38. So you see there's a difference there already. Then we had a base ear reading of 36.4 and an actual reading of the ear of 37.9. So it's jumping up again. And then when we did a comparison to the thermal camera, it was a 36.8 versus a 37.8. So as you can see, standing in the sun for 5 minutes can just change your temperature. So what can we decide from this? So all the devices here used were inaccurate to some degree. Like you can't actually use this device to measure someone's temperature properly if they've been out in the sun. So, you know, you really need to be acclimatized. The subject then would have to probably do a secondary test just to make sure that it was okay. So, you know, we had a 1.4 degree difference between the ear, or a 0.8 degree difference when compared to, say, 37 degrees. So when we go into the running test, so just trying to look here for the running test. So running test here, we had an outside temp of 24.6 and an inside temp of 20 degrees. Now, when we're actually doing this test, it was actually blowing a bit of a cold breeze out there. So we're trying to think whether this is actually going to affect skin temperature and surface temperature. But here, we'll go through the results now. So we had a base forehead thermometer reading of 36.6. And then when we actually went to read it using the forehead thermometer, it wouldn't even take those 3 readings. So, and then we went and did measured our ear. So the base ear was 36.9 versus the actual ear of 36.9. So bang on, spot on, you know, no different there. And then we go to the thermal camera. The thermal camera actually read a reading of 36.4. I was actually surprised to see that the forehead thermometer here was actually ineffective in measuring during that threshold. However, the thermal camera actually had a 0.4 degree difference. So yeah, that's kind of what we're going through here. The next test we did was the beanie test. The beanie test, we had a temperature of 19 degrees. Now this test here was actually a little surprising. Our ear thermometer, which I'm producing consistent results all day, started to produce an inconsistent reading or result, you know, basically after wearing that beanie for 15 minutes. I guess this is probably due to, you know, your beanie's above your head, it's covering your ears, and, you know, basically more heat's being trapped in. So we just found this result a bit different to what we were expecting. So in this particular test, we had a base forehead reading of 35.6 and an actual forehead reading of 38.7. We had a base ear reading of 37.1 and an actual of 37.9, so like a 0.8 degree difference here. And then when you went into measuring it against the thermal camera, we had a base of 36.8 and then an actual of 37.5. So you see here, when you found that if you're wearing a beanie or any type of headwear, you know, the devices actually struggle to measure the temperature effectively, especially if it was covering, say, the ears. So what did we get from this? Interestingly, the thermal camera actually only had a 0.4 degree difference when compared to, say, your base temperature that we've been going against. Both the forehead and ear thermometer produced, you know, I would say inaccurate results that would require further testing if you were using those to enter a building. So yeah, bit surprising there as far as different results that we got from using different thermometers. So the next test here was the indoor test. So when doing this test, we expected this test to basically produce the most consistent and accurate results. So what were our readings? We had a forehead reading of 35.9, an ear reading or ear thermometer reading of 36.9, and then the thermal reading of 36.6. During this test, we also found that all of the devices, you know, such as your ear thermometer, your forehead thermometer, read the same result, which is basically to be expected since we did acclimatize to the ambient temperature. Next one here was the cold water test. So we actually had an indoor temp here of 19 degrees. When we did this test, I was expecting all the devices except the ear thermometer to produce an accurate reading. But here's what we found. Base forehead was 36.5. We had a forehead, actual forehead thermometer reading, which it just produced an error. Couldn't even get a reading from that. Then what we found is the base ear was 36.6, and then actual ear thermometer reading of 37, and then a base thermal reading of 37, and an actual thermal camera reading of 36.5. So I was actually surprised as how well the thermal camera was able to still measure temperature within reason. As you can see from this thermal image, it shows where the bottles of water were, yet the thermal camera was still within 0.5 of a degree. So like we did all these tests, we found all these results, and then whilst we were doing these tests, we actually found other things that are probably worth mentioning that we thought was good to let you guys know. So our outside temperature measurement reading that we were using when we first started the test was in the shade. But then as we were progressing throughout the day and trying to measure temperatures, we found that our device was actually starting to go into sunlight. So obviously it was actually direct sunlight. So this actually started to affect the outside temperature readings. And then when using the camera near, say, internal glass doors. We found the camera was also picking up the reflection of the glass, actually measured the temperature as well. Now, this can be annoying when using the AI temperature software because that same person could actually possibly be measured twice and recorded multiple times, which is obviously not ideal. Other things we found is that we saw that when walking by the glass door, the thermal camera would actually pick up the heat signature from the glass as well, which was quite interesting in that it didn't cause the camera to read different readings, but it's just an observation as to what we actually saw. The next thing we saw was that the ideal measuring distance for this camera is actually between 1 and 2.5 meters. So we found that the camera, when we put that outside, was actually still able to pick up distances. Like we're probably been talking about 5 meters here. Could still pick up your temperature reading, but as you got closer to the camera, you could see the temperature slightly increasing. So it was, yeah, just an interesting observation that we found there. So what do we get from this? What did we actually learn? Surprisingly enough, the forehead thermometer didn't do as well as I thought. You see, we see this type of device being used to measure people's temperature all the time, you know, whether you're walking into a building. But what we found through our test is depending on the environmental conditions and where that person's actually been exposed, you know, whether they've been exposed to sunlight, cold wind, have they been wearing a beanie or any type of headwear, the forehead thermometer actually was prone to providing inaccurate readings. But by far and the most accurate and consistent results came from the ear thermometer. However, is this type of device practical to use in a real world scenario? Like, can you effectively test large groups of people quickly? It does give you accurate results, but the process of measuring that temperature via the ear then would create a backlog of people waiting outside the premises to enter, so effectively defeating the purpose. Now to the thermal camera. Can you effectively use this thermal camera to measure temperature? Look, if you're going to use this camera inside and allow people when entering a building to acclimatize and you can guide them through a process, then yeah, it can be very effective. Especially if you couple this camera with the HikVision's black body, you can actually get results down to within a tolerance of, you know, 0.2 of a degree. But is this going to be possible? Like, are you going to be able to create this room and allow people to wait 5 minutes, sit down, then allow them to get up and then measure the temperature? Maybe you can, maybe people are willing to do that, but you do risk having a backlog of people waiting outside. What we found though is if we could set this camera up the way we did our entrance test, that is the preferred and best option to use this camera. You know, you can mount this camera to the ceiling or you can mount it to a wall. You can actually measure people's temperatures from a distance just as they enter or they're in. Look, it does a great job, but if the environmental conditions weren't quite correct, you may get some slightly different results. And that comes into question is summer once again. Ambient temperatures are quite high outside. Does that play a role or does that play a factor? Another thing is sometimes we think we can actually remove the human presence completely when we install one of these cameras. Look, you're still going to need someone to monitor people walking into the building, especially if they've got a high temperature. So you're going to need to stop them from going any further. Unless you've got a boom gate or a turnstile, then maybe you could start getting rid of that, that human presence and human monitoring. But the good thing is if you do decide to get rid of that, this camera allows you to send a notification to your phone. You know, you get a pop-up, a message saying, look, someone's with a high temperature. You can also get an email sent to you as well. It also, what it does is it allows it to create a log, you know, a log of people. So when they're walking in, it captures their face, measures their temperature, and just allows you to get a bit more of a traceability factor. Look, it's not bad. The camera at the end of the day, it does give accurate results within reason. So you can use this camera as a point of reference and then use as a double check whether that's a forehead, ear thermometer to see what the actual person is, just in case something's a bit amiss. But really, in all honesty, to effectively measure someone's temperature, you need to do it internally and have the room at least to a consistent temperature where your body's had time to adapt. Only then can you get this accurate reading that you're after. So, is a thermal camera worth it? You know, is it worth the investment? Look, if you're after for something that can give you peace of mind and measure that person's temperature, then yes, it's worth it. But you're after a device that you can accurately measure someone's temperature and identify whether they've got a fever, then no, it can't. So we've actually thoroughly enjoyed doing these tests, and we're going to do, get more cameras. We're going to do more tests in this. So if you found this video informative, Just subscribe to our YouTube channel, like us on Facebook, follow us on Instagram, because we're constantly putting new content out there where just allows you to see what's happening in the market and gives you a complete review of how to use products, what the product's used for. So hope you've enjoyed this, and we'll catch you next time.